Okay, hello everyone. My name is NEERJA ARORA and I'm working as an assistant professor in CSC department at Ajay Kumar Garg Engineering College, Ghaziabad. Today I'm going to discuss a topic that is minimum spanning tree, which comes under the subject design and analysis of algorithms having code KCS 503. Okay, let's start with the topic. So in today's lecture we will discuss about the graphs, trees, spanning trees, minimum spanning trees, and the two greedy algorithms, that is Prim's and Kruskal's algorithms, to find out the minimum cost spanning trees. And at last we will also discuss the difference between Prim's and Kruskal's algorithms, which are used for finding the minimum spanning trees. So before going to start with minimum cost spanning trees, we must know about the difference between a graph and a tree. So what is a graph? A graph is basically denoted by a capital G, F, V and E, where V is a set of vertices and which are interconnected by a set of lines which are known as edges. As you can see in this particular graph, we have 1, 2, 3, 4, 5, 6. 6 vertices are there and these vertices are connected by a lines. These lines are known as edges. So your graph may be a cyclic graph or a acyclic graph. Cyclic graph means in which if there is a loop or cycle is present in your graph, then it is cyclic. Otherwise, if there is no cycle present in your graph, it will be a cyclic graph. This graph is a cyclic graph. As you can see, we have nodes 1, 2, 3 and 4 which are connected by 4 edges, and these edges are making a loop or a cycle. So this is a cyclic graph. Otherwise, if there is no single cycle present in your graph, it will be acyclic. Also, your graph may be a directed graph and or undirected graph. Directed graph means if you have two vertices, suppose 1 and 2, and there is a edge which is starting from the vertex 1 and ending to the vertex 2. So, okay. So there is a direction. We are started from vertex 1 and ending to the vertex 2. This is a directed edge. And if directed edges are present in your graph, then that graph will be directed graph. Otherwise, it will be undirected. So this is a undirected graph. Okay. And also, if in a graph you have n number of nodes or vertices, then that graph will contain less than or equal to n into n minus 1 by 2 number of edges. Okay, now what is a tree? Basically, we can say tree is a part of a graph. Okay, so if you have a connected acyclic graph, then it will be a tree. Connected graph means a connected graph is a graph in which there is always a path from a vertex to any another vertex present in your graph. It means there is no independent vertex present in your graph. Okay, जितने भी vertices हैं आपके ग्राफ में, वो सारे vertices आपस में linked होंगे, connected होंगे. There will be no independent or separate vertex present in your graph. Then that graph will be a connected graph. And acyclic, I have already discussed. So a tree with n number of nodes will contain exactly n minus 1 edges. Okay, so this is a difference between a graph and a tree. In a graph, you will have n into n minus 1 by 2 number of edges, but in a tree, you will have exactly n minus 1 edges, where n is a number of nodes or vertices present in your graph. So let's come to the topic, that is spanning tree. So what is a spanning tree? Suppose we have given a graph that is G of V and E, and if we have to construct a tree structure for that graph, that is G dash, and which is having the vertices V dash and edges E dash for particular that graph, such that the formed tree structures follow the below mentioned constraints. Two constraints are there, then that tree structure is known as spanning tree. Okay, so you are given a graph G having vertices, number of vertices V and number of edges are E. And for that graph, if you will construct a tree which can be represented by a G dash having number of vertices V dash and number of edges E dash, and if that tree follows these two constraints, then that tree will be called as spanning tree. Okay, so first constraint is that the number of vertices in your spanning tree or a tree will be equal to number of vertices already available in a graph G. And second constraint is that number of edges in a tree is equal to number of vertices in a graph minus 1. Okay, if these two constraints are satisfied, then that tree is known as a spanning tree. Another property of spanning tree is that there will not be any cycle. कुछ cycle नहीं present होनी चाहिए आपके spanning tree में. If there is a cycle, then it will not be called as a spanning tree. So this is an example. Suppose this is an undirected connected graph is given, and for this graph you can have various spanning trees. Okay, you can various spanning trees. So here we have 4 number of vertices and number of edges are 6. Vertices are 4 and number of edges are 6. But in spanning trees, number of vertices will be same as your graph. जो first constraint है कि number of vertices in spanning tree will be equal to number of vertices in your graph. तो vertices same है, but number of edges कितनी होंगी? Number of edges will be equal to number of vertices in a graph which is 4 minus 1, that is 3. So 3 edges will be present in your spanning trees. Okay, तो 3 से ज़्यादा edges आपकी यहाँ पे नहीं होंगी spanning trees में, and there can be multiple possible spanning trees for a single graph. Okay, this is another example in which we have number of vertices 6 and number of edges are 1, 2, 3, 4, 5, 6, 7. 7 edges are there. So in possible spanning trees, number of vertices will be equal to same, that is 6, and number of edges will be equal to number of vertices in a graph, that is 6 minus 1. 6 minus 1 is equal to, so number of edges in your spanning tree will be 5. So as you can see in these spanning trees B, C and D, in this spanning tree we have 1, 2, 3, 4, 5 edges. Here you also have 5 edges. Here also you have 5 edges. But there is no cycle. ठीक है, cycle नहीं होनी चाहिए. So if you are given a complete graph, तो कितने possible spanning trees हो सकते हैं? If there are n number of vertices, it is equal to n raised to power n minus 2. Okay, so for a complete graph, you will have n raised to power n minus 2 possible spanning trees for a given graph with n number of vertices. So our problem is, or our topic is to find out the spanning tree which is having the minimum cost. Okay, you have to find out the minimum cost spanning tree. So till now we have discussed unweighted graphs. Okay, so for an unweighted graph you can have various spanning trees. But if you are given a weighted graph means in that graph each edge will having a known negative number, which is a weight of the edge, or you can say cost of the edge. So for a weighted graph, if you are having weights or costs for each edge, then for that weighted graph there can be multiple spanning trees possible, and you have to find out the minimum cost spanning tree which is whose total weight is minimum or small as possible. क्योंकि edges का जो weights का sum है वो आपका minimum होना चाहिए और smallest होना चाहिए जितना भी minimum है. So that spanning tree will be known as minimum cost spanning tree. So let's understand it with an example. So this is a weighted graph in which we are having 4 vertices A, B, C and D, and number of edges are 1, 2, 3, 4, 5. 5 edges are there having different weights value or cost value. So for this particular graph we can have, suppose spanning tree 1, there can be another possibility spanning tree 2, there can be another spanning tree, this is 3 and this is spanning tree 4. Okay, so number of edges कितनी है इन spanning trees में, कितनी होंगी? Vertices जो अवेलेबल हैं आपके ग्राफ में इज 4, तो नंबर ऑफ एजेस इन अ स्पैनिंग ट्री विल बी v minus 1, that is 4 minus 1 is equal to 3. So 3 edges will be there. Okay, so for ST1, if we are calculating the sum of the edge cost, then it will be 11. So कैसे आपका calculate हुआ 11? So for the edge AB we are having cost value 5. For edge BD we are having cost 2, and for C and D we are having cost 4. So 7 plus 4, 11. Similarly for ST2 we are having cost 5, 10 or 4, 14. And for ST3 we are having 5 plus 1, 6, 6 plus 4, 10. And for ST4 we are having cost value 5 plus 2, 7 plus 1, 8. So for the spanning tree 4, we are having the minimum cost value for the tree. Okay. So this is the minimum spanning tree and it will be selected and can be used for solving the various types of problem. So this is the minimum cost spanning tree for this particular graph. This is how we can calculate or find out the MST. But so till now we have discussed or understand the basic method or naive method. What we did in this method, we will have we first generate all the possible spanning trees and then calculate the overall sum of the edge weights for each generated spanning tree, and after that we have to determine the minima of all those spanning trees which will cost us more time and memory. Obviously in this method is very time consuming and more not memory efficient, because here we have to generate all possible spanning trees, then we calculate the sum for each spanning trees. So this will take time and more memory. So this is not a better approach. So for finding the minimum cost spanning tree directly, we can use the greedy algorithms. Okay, so first is a Kruskal's algorithm and another one is a Prim's algorithm. So by using these algorithms, we can calculate or find out the minimum cost spanning tree in a very minimum time, and these are memory efficient also. So let us discuss them one by one. So basically Kruskal algorithm, what it did, it makes a locally optimum decision in the hope of finding the global optimal solution. Hence this algorithm can also be considered as a greedy algorithm. So locally level पर immediately जो आपको best solution लग रहा है, best choice है, optimal choice है, उसे आप choose करते हैं किस hope में कि at the end in the future you will get the optimal solution, you will find out the global optimal solution. So these are the steps that you have to follow in Kruskal algorithm to find out the minimum spanning tree. Step 1 is, first you have to remove all the loops or cycle and parallel edges if they are present in your graph. Then after that you have to sort all the edges in increasing order of their edge weights, and after that you have to pick the smallest edge, or you can say minimum cost edge, and add it in the spanning tree. And in the step 4 you have to check if the new edge creates a cycle or loop in your spanning trees, whether it is or not. If it doesn't form a cycle, then you can include that edge in MST, otherwise you have to discard it. And at last you have to repeat these steps from 2 to up to 6 until it includes v minus 1 number of edges in your MST. So this is an example. Basically this is a graph having, I think this is a light edges. So this is a graph. In this graph we have 1, 2, 3, 4, 5, 6 number of vertices, and 1 2 3 4 5 6 7 8 9 10 11 number of edges, and there is also a cycle and parallel edge present. So what Kruskal algorithm says, first we have to remove the loop or parallel edge present. So this is a loop, so first we have to remove this loop from our graph. Okay, then also there is a parallel edge, so we also have to remove this particular parallel edge. So there are two edges here in between A and B. One is edge having cost 6, another edge is having cost 9. So in these two options we will ignore this edge which is having the highest edge, highest cost value. So we will retain the edge which is having the minimum cost value, which is 6. Okay, so in the first step we will remove the loops and parallel edges from the given graph. Then in the step 2, what we did, we will arrange or sort all the edges in the increasing order of their weights. So in for a given graph, the edge BD is having cost minimum, that is 2. Then after that edge DT is having cost minimum cost, that is 2. Then AC having cost A3 up to the edge SC which is having the cost value 8. So we have arranged the edges in the ascending order of their cost value or weight value. Now in step 3 we have to pick the minimum cost edge from this edge list and include that edge in a particular graph. So here the minimum cost edge is BD, so we will include this edge BD in our graph. Okay, then after BD we have the DT edge which is having minimum cost, that is 2. So we will also include DT in our graph. Okay, and its cost is 2. But every time when we are adding the new edge in a graph, you also have to check whether it is forming a cycle or not. If it is not creating a cycle or forming a cycle, then only we have to add or include that edge, otherwise we have to ignore. Now BD and DT are already included. Next edge is AC, so we will add edge AC also in our graph. It is not forming a cycle, so no issue. After AC we are having next edge CD, तो CD को भी हम यहाँ पे include कर लेंगे, ठीक है. Then after that we have edge CB, but अगर हम यहाँ पे CB को include करते हैं then it will create a cycle. Okay, so the edge CB will create a cycle, so we will ignore this edge and we will not add or include this edge in our spanning tree. So next edge is BT, तो CB को हमने include नहीं किया. Next edge is BT. So in BT, if we are adding or including the BT in our tree, then it will also create a cycle. So we will not also include the edge BT. And after BT we have AB, and AB को भी हम include नहीं कर सकते because it will also create a cycle. So after that we have SA. SA we can include that because it is not creating a cycle. And at last we have SC. So SC को भी हम include नहीं कर सकते because after including the SC the cycle will be formed. So output will be this one. So output will be, we have to include AC. Okay, first we have included BD. Yes, we can include BD. Then after that we have also included DT, and AC is also included, CD is also included, but we have not included CB because it was creating a cycle. We also have not included BT because it was creating a cycle. We have not included AB because it is also creating a cycle, but we have included SC and not included SC because it was creating a cycle. So this is the final minimum spanning tree. And total cost क्या रहेगा इसका बेटा? 7 plus 3 10, 13 and 4 17. The cost of this spanning tree will be 17. So this is how Kruskal's algorithm work. Another is a Prim's algorithms. So basically Prim's algorithms begins with a single node or any random node for creating a spanning tree. But in case of Kruskal algorithm, we have started with the minimum cost edge. But in case of Prim's algorithm, we have started to build up the minimum spanning tree with a single node or any arbitrary node. And then it adds up the adjacent nodes one by discovering all of the connected edges along the way under some constraints. Thus, we can also say that the Prim's algorithm finds out the global best transfer by making the locally optimal decisions, as it is also a greedy algorithm. So these are the steps that you can follow in Kruskal algorithm. Step 1, same as Kruskal algorithm. You have to remove all the cycles or loops and parallel edges if they are present in your graph. Then after that, you have to choose any arbitrary node as a starting node or a root node. And in step 3, you have to check the outgoing edges from the recent visited node and pick an edge having the minimum edge weight which is connecting to the fringe vertex. So what is fringe vertex? It is basically the adjacent node to the recently visited node. Okay. We can understand it with a better with an example in the next slide. So in step 4, you have to add the selected edge to MST only if it doesn't form a closed cycle or loop. And in step 3, you have to keep repeating the step 2 and 3 until the fringe vertices exist and then end. So let us discuss it with an example. We have considered this same example as we did considered in Kruskal's algorithm. So first step will be same. You have to remove the cycle and the parallel edge. Then after removing the cycle and parallel edge, you have to choose any node as a root node. So here we have considered the node S as a root node. So this is a root node, starting node or root node of the minimum spanning tree. Then after that, we have to check the outgoing edges and select the one with the less cost. So from this root node of recently visited node, we have two outgoing edges. One is SA and another is SC. So if we consider SA, it is having cost 7, and for SC the edge is having cost 8. So which is minimum? 7. So we will consider the outgoing edge which is having the minimum cost value, that is SA having cost 7. So we will not include SC in our tree, we will include SA, edge SA. So till now we have included the node S and node A. We have visited the node S and A of your graph. Now next, what are the options? We have two nodes S and A. Okay. So from S, the outgoing edge is S to C, and from vertex A, we are having outgoing edge A to C and also A to B. So SC, the edge SC is having cost 8 and edge AC is having cost 3 and edge AB is having cost 6. तो इन तीनों ऑप्शंस में मिनिमम कॉस्ट आपकी है A to C. Okay. So from the available options, available edges, we are having minimum cost edge is AC, which is having cost 3. So we will include AC, not SC and AB. Okay. So till now, we have included 3 vertices in our spanning tree, S, A and C. Okay. So now we have 3 visited nodes, S, A and C. So from these visited nodes, what are the options or edge list? Outgoing edges अब कौन कौन सी हैं बेटा? One is A to B, another is S to C. Now we have also visited vertex C now. So from vertex C, outgoing edges are C to B and C to D. So from A to B, cost is 6, and from S to C, cost is 8, and from C to B, cost is 4, and from C to D, cost is 3. सो इन एज लिस्ट में से सबसे मिनिमम एज कॉस्ट है C2D. सो वी विल इंक्लूड CD इन आवर ट्री, नॉट SC, AB और CB. So this is how Prim's algorithm works. So at last we have 4 visited nodes S, A, C and D. So now what is the edge list? Now we are left with S to CH, and from A outgoing edge जो remaining है that is A to B. From C outgoing edge जो remaining है जो अभी तक हमने include नहीं की आपके tree में that is C to B. And from visited vertex D we are having 2 outgoing edges D to B and D to T. So S to C having cost 8, A to B is having cost 6, C to B is having cost 4, D to B is having cost 2 and D to T is also having cost 2. The minimum cost edges are D to B and D to T. So first check they would not form a cycle. If they are not creating a cycle, then we'll include both these 2 edges D to B and D to T in our spanning tree. Okay. So now T is also included or added in our tree. And we are having 1, 2, 3, 4, 5 number of edges. Right. And in minimum spanning tree मैंने आपको बताया था second constraint क्या था? We are having 1, 2, 3, 4, 5, 6. 6 vertices are there. So number of edges in spanning tree will be 6 minus 1 equal to 5. 5 edges will be there in your spanning tree. So here we are having 5 number of edges. It means spanning tree is completed, and this is the minimum cost spanning tree, and cost of this spanning tree will be 7 plus 3 10, 13, 15, 15 plus 2 17. Right? So this is how Prim's algorithms work. So we can calculate or find a minimum cost spanning tree by using these 2 algorithms in a very minimum time. So this is a comparison of Kruskal's and Prim's algorithms. So in Kruskal algorithm, it starts to build the minimum spanning tree from the edge, carrying the minimum weight in the graph. So here we are starting with by adding the minimum cost edge in your graph, in your tree. Then, but in Prim's algorithm, we are starting the build the minimum cost spanning tree from any node of vertex from your graph. Kruskal algorithm traverses one node only once, but in Prim's algorithm, it traverses the every node more than one time to get the minimum distance. Third difference is that the time complexity of Kruskal's algorithm is big O of E log V, where E is the number of edges and V is the number of vertices. But in case of Prim's algorithm, the time complexity will be big O of V square, where V is the number of vertices and can be improved up to big O of E log V if we will use Fibonacci heaps as a data structure. Kruskal's algorithm run faster in sparse graph, and the Prim's algorithm run faster in dense graphs. And Kruskal algorithms can be used to solve the TV network problem or finding out the efficient LAN connection or network. But Prim's algorithm can be used to solve the traveling salesman problem, network generating the network for the roads, and also it can be used to solve the rail tracks connecting all the cities extra. So there are various applications or areas where we can use the Prim's or Kruskal algorithm to solve the problems. So this is all about the Prim's and Kruskal algorithms. Thank you.